This video is about Chapter 7, Section 4. We're looking at Objective 3 again, which is solving problems using the Pythagorean theorem. This time, though, we're going to be looking at Example 4. This example is obviously an application problem, and we are asked to solve something that we need to read. An animal holding pen situated between two buildings at a right angle to each other will have walls as two of its sides and a fence on the longest side. The side with the fence is 20 feet longer than the shortest side, while the third side is 10 feet longer than the shortest side. Find the length of the fence. Well, first all I can say is, yikes! This is not a very well written application problem. On the other hand, it resembles a lot of what you see out in the world, where people are not writing carefully and hoping for you to solve it. They're just getting information out. So let's start by going back and looking in the problem. So an animal holding pen situated between two buildings at a right angle to each other. And situated, make sure you know what that means. We'll have walls as two of its sides. Ooh, that's important. And a fence on the longest side. And longest really tells me a lot. The side with the fence is 20 feet longer than the shortest side. So the fence is 20 feet longer than the shortest side, while the third side is 10 feet longer than the shortest side. Find the length of the fence, and that's what they want from you. They want you to find the length of the fence. Okay, well, we have some more interpreting to do. Situated means it's placed between two buildings, and the two buildings are at a right angle to each other. So we know we've got that. So here's building number 1, and here's building number 2. And it says that between them is a right angle. Okay? Now, they also said that one of the walls of the building is the part of the pen, and the other is part of the pen. And then they told us that the third side is a fence. Okay, so it's starting to come together. I want to go back though and do some more analysis with the problem. You may remember that I talked about when I'm reading these kinds of things, I look for where they're comparing the different measurements. And here it says the side with the fence is 20 feet longer than the shortest side. Remember, than usually points to the variable you're interested in. Same thing over here. The third side is 10 feet longer than the shortest side. So clearly, the short side is interesting. So here's a new drawing of our triangle. So my basic variable will be, I'm going to pick S for short. And the longest, the side with the fence, that's this side, is the short side plus 20. Again, the fence is 20 feet longer than the shortest side. And here's the other side. The third side is 10 feet longer than the shortest side. So I'm going to start with S, and then I'm going to add to that 10. So those are my basic measurements, and since I'm dealing with a right angle, I know that I can rely on my old friend Pythagoras to get me out of this bind. Because even though I don't have a number, I have the relationship between them. So let's take a look. We'll start a new page to work on those. So Here we have, again, a squared plus b squared equals c squared, and I used some color coding to help you see what I'm talking about. So here a squared is s squared, b squared is s plus 10 squared, and then s plus 20 squared is c squared. So again, color matching. And now I'm going to do some work. So here I'm going to have s squared again, plus I'm going to multiply the factors here. And I could do it the long way, or I could use my magic skills and know that that is the same as s squared plus 20s plus 100. And this is the same as s squared plus 40s plus 400. Okay. Now, remember, I need to get that to look like this. So I have to do some cleanup work. And the first thing I'm going to do over here is I'm going to combine these like terms. So I'll have 2s squared plus 20s plus 100 equals s squared, and there's nothing to combine here. I want this side over here to be 0, so I'm going to add the opposite. Let's change colors on that. And what I do to one side, I have to do to the other. So I'm going to subtract the same from here. And that's going to give me a new format. 2s minus 1s, that leaves me s squared. That's minus 20s, and that's minus 300. And that all zeroed out. And now this looks like this, right? So we want to start factoring. So here's our problem. Now, again, you might be able to figure that out, or if you can't, like me, let's see if we can hack it apart. So that was the secret 1 times negative 300. So that's my starting point. Because it's minus, they're going to be mixed. So that's either going to be plus and minus or minus and plus. So let's do it. So 1 times 300, let's skip ahead a little bit. I think we can sort of cut to the chase. We have to have them be negative 20. So, well, let's see, 2 and 150, 3 and 100, 4 and 75, 5 and 60, 6 and 50, well, we could keep going, but I happen to know that it's 30 and 10. And it's going to be this and this, because the difference between 30 and 10 is negative 20. So let's take it apart up here. S squared. Oh, heck, we can do this one. We don't need to group it. So S minus 30 times S plus 10. That gives us 0. S equals 30. S equals negative 10. And remember, what are we going to use for length? Do we want this one or this one? I want this one. not this one. So let's test it. Let's see if that's true. So 30 squared plus 20 times, oops, sorry, we're going to go back to the original one. So we have S is 30. So 30 squared plus 30 plus 10 squared equals 30 plus 20 squared. 900 E plus 30 plus 40, 30 plus 10 is 40, and 40 squared would be 1600, and 30 plus 20 would be 50, and 50 squared would be 2500. And since 9 and 16 is 25, yay, we won! Okay, so what we're going to do now is you are going to stop, that's a T really, and copy. And then you're going to go to you try number 4, and that's on page 407.